Okay, so now we go up from our second degree approximation or quadratic approximation to a third degree or cubic approximation. So we take our quadratic approximation that we already had, f of a, f prime of a, x minus a, plus f double prime of a over 2, x minus a squared, and we add on a cubic term with C3. Now, we still want the same requirements from before, f of a to be, p of a to be equal to f of a, the derivative, the second derivative to agree, and they will. We also would now like, since we have a cubic polynomial, the third derivative to agree with our original function. So if we took the third derivative of this, that would be 3c3, x minus a would be left over the first time, and then times 2 c3 x minus a, and then when we do the third derivative times 1, derivative of x minus a is just 1 at that point, we would have p triple prime, third derivative of this thing, would be 3 times 2 times 1 times c3 equals f triple prime of a. So c3 is the third derivative of a divided by 6. Well, what's going on with this 6? Well, 6 is 3 times 2 times 1. In the previous problem, the 2 could have been thought of as 2 times 1. And of course, the dividing by 1, which we didn't write because we don't write that out, could have been thought of as dividing by 1 factorial. So the actual pattern is this. The third polynomial is f of a times f prime of a plus f prime of a x minus a, but we can write it as divided by 1 factorial plus the second derivative divided by 2 factorial x minus a squared plus the third derivative divided by 3 factorial x minus a to the third. Because the pattern would be if we did this with a fourth power, then the first time you did the derivative, you'd multiply by 4. The next time you'd multiply by 3, then by 2, then by 1. For the P4 approximation, we'd be dividing by 4 times 3 times 2 times 1, or 4 factorial. And that pattern continues. Okay, so we want to take now and compute our P3 polynomial for the square root of x. Still around the same point as before. Sticking with the same point because we can just take the stuff from before, our 1 plus 1 half x minus a minus 1/8 x minus, I'm sorry, 1 plus 1 half times x minus 1 minus 1/8 times x minus 1 squared. And then we just need to figure out the third term, computing f triple prime of a, and then dividing by 3 factorial, which is 6, with our x minus a. So remember, we had, from just a little bit ago, that the second derivative was negative 1/4 times x to the minus 3 halves. So we go ahead and use the power rule again. So we would multiply by negative 3 halves. So the negatives would cancel out, and we would have 3/8 x to the negative 5 halves. 3/8 x to the negative 5 halves. So there we have our third derivative is positive 3/8 x to the negative 5 halves. And then we want to evaluate that at our pivot point, x equals 1. So f triple prime of 1 would just be 3/8 because 1 to all that stuff is just going to be 1. And then we're going to take that, divide it by 6, or 3 factorial. So we divide by 3 factorial, which is, again, 6. So we're going to have 3/8 divided by 6, which would be the same as 3/8 times 1/6, which would simplify to actually just be 1/16. So our C3, our coefficient for the third degree polynomial, is 1/16. And then putting it together, we take our quadratic term, quadratic polynomial 1 plus 1/2 x minus 1 minus 1/8 x minus 1 squared. And then we just add on the additional term there, 1/16 x minus 1 cubed. The last thing I want to show you here, I hope it still shows up well when I come over to the graph, is here's my three approximations. Of course, the red graph here on this picture is my square root graph. The blue line is my tangent line approximation. The green graph here is my second degree approximation. And then it's a little hard to see because they're all starting to kind of blend together here a little bit. But maybe if I turn a couple of these off here, you can see now the third degree approximation. And just kind of comparing that with the green one, you can see it does stay a little bit closer, just a little bit longer. There's my third degree approximation. Again, centered around the point right here, x equals 1. Okay, so you can see how it does improve here as we go from first degree approximation to second, and then from second to third. As we go up to a higher degree polynomial, we keep getting more consistent with the graph for a little bit longer. Okay, and so that's our third degree approximation.